Hello dear all. Trig functions. What are trig functions? In mathematics, the trigonometric functions, and they are also called the circular functions, are functions of an angle. They relate the angles of a triangle to the lengths of its sides. What does that mean? Especially in the right angle triangle, we are all going to talk about trigonometric functions in a right angle triangle. So the triangle should be right angle first. And when we say trigonometric functions, we want to relate the angle A, for example. We want to relate the angle A, which is not the right angle, any of these two angles, A or B. And here we are going to talk about angle A. So we want to relate the angle A to the other sides, to the three sides that are beside it and opposite it. So we have the side that is close to A. This is called the adjacent. So the adjacent side here is the side that is adjacent or near the angle A. And the opposite side is the side that is opposite to angle A. And of course, the hypotenuse is the side that is in front or opposite to the right angle. So the three trigonometric functions, or the main trigonometric functions, are sine, cosine, and tan. The number one, sine A. Sine A is the function which relates the opposite side over the hypotenuse. So sine A is opposite over hypotenuse. The second one is cosine A. Cosine A is the adjacent over the hypotenuse. And tan A is the opposite over the adjacent sides. So again, have a look at them. Sine A, opposite over hypotenuse. Cosine A, adjacent over hypotenuse. And tan A is opposite over adjacent. Some examples. Write each trigonometric ratio as a fraction and as a decimal rounded, if necessary, to the nearest thousandth. Number one, sine A. So here is the angle A. And sine, we know that sine is the opposite over the hypotenuse. So where's the opposite? The opposite is 12. So it's equal to the side BC, which is the opposite, over the hypotenuse, which is AB. And BC from here is labeled as 12, and over the AB, which is the hypotenuse, 13. 12 over 13 is approximated to the nearest thousands as 0.923. So you can use the calculator here to find this and then round it. The second one, cosine A. And we know that cosine of an angle A is the adjacent, which is 5, over the hypotenuse, 13. So it's equal to the side AC over AB, that is 5 over 13. Again, using the calculator, you can find the number and round it to the nearest thousands to 0.385. Cosine B. Cosine B, this is the angle B. And cosine means the adjacent to over the hypotenuse. So where is the adjacent to angle B? Adjacent is the 12. So here is BC over AB. And here is again 12 over 13. That is approximated to 0.923. If you here notice that sine A and cosine B are equal to each other, because both of them, the adjacent for B is the same as the opposite of A, and the adjacent for A is the opposite of B. So sine A and cosine B are equal, and of course cosine A is equal to sine B. Another example. In each right triangle, find the tangent, and tangent means the tan of each angle that is not the right angle. So here we want to find the tan for A and the tan for B. So let us write here tan A. We know that tan A is the opposite over the adjacent. Tan is the opposite over adjacent. And what is the opposite of A? Opposite is 8. And what is the adjacent is 6. So it is 8 over 6, and using the calculator it will be 1.33. Now what is tan b? Tan b is again the opposite over the adjacent, and the opposite here is 6, and the adjacent is not here, adjacent is 8, so it's 6 over 8. So why didn't I take the adjacent 10? Because 10 is not the adjacent, 10 is the hypotenuse, so I do not use it in tan. 6 over 8 using the calculator is 0.75. Another example, use the tangent or the tan to find the unknown side length. Okay, so here he wants you to find the side length QR. So this is the unknown. You want to find the QR, and you are given the angle. Here is another type of questions. Here you are given the angle, and you're given the opposite side, and you are required to get the adjacent side. So I ask myself, what function relates the angle to the adjacent and the opposite? Is it the sine or cosine or tan? Of course, it is not sine and it's not cosine, it is the tan that relates the adjacent with the opposite. So we write tan 60 degrees equals 7.0 over QR, and this is the unknown. So from the calculator you can get tan 60, and this is now an equation. You can solve it for QR. So to get QR, I write QR is equal to this 7.0 divided by tan 60. So I exchange the places. I just exchange the place with QR and the tan 60 to get the QR. And QR on the calculator, you calculate 7 divided by tan 60, you will find it's equal to 4.0, which is just 4. Now here you find PQ. This triangle is a right angle in Q. This is the right angle here. It looks weird, but it looks like this. This is a triangle, right angle triangle, and this is the right angle here. And this P, this angle is 85 degrees, and the opposite to it is 9. And we are required to get or to find out what is PQ. So what is PQ? This is the unknown. Again, what is the relation between the opposite and the adjacent? It is tan. So tan is the function that relates the opposite with the adjacent. So we write tan 85, which is the angle given here, equals the 9 over the unknown PQ. So again, we exchange the places. So we get here PQ. So I again exchange the place with the tan. So this means that PQ equals 9 over tan 85. On the calculator, you calculate 9 divided by tan 85, you will find it's 0.79. Find the unknown length x in each right triangle to the nearest tenth. This is another type of questions. You are required to get the x. Okay, and you are also given the angle 37. And what is this? Is this the adjacent or the opposite or the hypotenuse of the triangle? Okay, so you just have to be more careful. You do not write this is the adjacent, this is not the adjacent, the hypotenuse. So you ask yourself, what function relates the angle to the opposite and the hypotenuse? Opposite and hypotenuse, remember, it is the sine. So this means that sine C equals AB over AC, and AB is the x and AC is the hypotenuse given here. So we write sine C, and C is 37 degrees, equals AB, that is x, over AC, that is 15. So to get x, this is an equation in x. To find x, I multiply 15 to the other side. So x is approximately equals to 9.0. Of course, you multiply sine 37 times 15 on the calculator, you will find it's equal to 9. Here you are given a right triangle. Again, the hypotenuse is 27, the angle is 53, and you are required to get x. X here is the adjacent to the angle. So again, you ask yourself, what is the function that relates the adjacent to the hypotenuse? Yes, it is cosine E equals the adjacent, which is EF, over the hypotenuse DE. So cosine E, I write E is 53 degrees, and EF, that is the unknown x, over the hypotenuse 27. So what is x? I will multiply 27 to the other side, and x here remains on this side, so x is approximately equal on the calculator 16.2. Find the measure of the angle specified for each triangle. Use the inverse tangent or tan inverse function for your calculator. Round your answer to the nearest degree. Here you are given a right angle triangle, and you are given the adjacent of A and the opposite of A, and this is unknown, and you are required to, so this unknown, the hypotenuse is not known, no problem, but the unknown here is find A. So find A. To get A, we will use the relation what function relates the adjacent with the opposite. I know that tan A is equal to 6.8 over 3.0, but I need to find out what is A. So to do this, I will write here measure of angle A equals tan inverse 6.8 over 3.0. And we have a button on the calculator that makes tan inverse. Tan inverse means what is the angle that is, its tan is 6.8 over 3. So we do this on the calculator, and we will find out that the measure of angle A is equal to 66 degrees. The last example, find measure of angle R. So here you have a right angle triangle. You have, this is the R that is unknown, and the adjacent is 24, and the opposite is 9. So again, we will use, we know that tan R equals 24, is equal to 9 over 24, the opposite over the adjacent. So to find the measure of angle R, I write here measure of angle R, and I bring this tan here with the inverse operation over 9, tan inverse of 9 over 24, and on the calculator you will find out that measure of angle R equals 21 degrees. Hope you understand